Hello everyone and welcome to today's lesson 9.2.4. What kind of number is it? We're talking about real numbers, okay? Real numbers are basically all the numbers that you can think of. Yes, I know the opposite of real is imaginary, and there are imaginary numbers out there, but you can't imagine them just yet. Today we're going to talk about two different types of numbers called rational and irrational. In previous courses, you worked with decimals that repeated and terminated, right? You know that some decimals stop, like 1/2 is 0.5, but then you have repeaters like 1/3, that's 0.3 with a bar. Okay, those are repeaters and terminating. In the previous lesson, we talked about square roots and how to take square roots. Some square roots are perfect squares, like the square root of 9. The square root of 9 is 3 and is therefore a rational number. However, there are some numbers that do not repeat. That means that they don't have a pattern and they don't terminate. They don't stop. That means that they are irrational. Like this number off to the side in your notebook says the square root of 2 is 1.414213562237. There's no pattern. That does not stop. It just, that ... means it keeps going. And so when we are dealing with the square root numbers, we have to think, is it rational? Does this number make sense, or is it irrational? So I want you to notice these problems are perfect to be doing with a calculator. You need a calculator handy so that you can solve these problems. So if I were doing problem letter A, I would type that in the calculator and I would get 2.5. And now I can make the decision. Is this a rational number that makes sense, or is it irrational because it doesn't follow a pattern? Well, 2.5 is a terminating decimal, so I know it is a rational number. This number makes sense. I know that it's a regular old number, $2.50, right? Problem letter B. The square root of 100. If you typed the square root of 100 into a calculator, you would get the number 10. 10, of course, is rational. So I'm going to write down that this is a rational number. Notice these are both terminating numbers. That means that they stop. And if I did run into a decimal that went on forever, I would ask myself if it had a pattern. Now, the square root of 7. If I type the square root of 7 into a calculator, I would get 2.64571311 ... Okay, and I ask myself, well, I notice it went on forever. Is there a pattern to this? Absolutely not. This is an irrational number. Okay? Here is the trick to irrational numbers. Most irrational numbers are pi and non-perfect square roots. Okay? Now, when I say non-perfect, that would be like the number, I don't know, 20. If I was talking about perfect square roots, that's 1, 4, 16, 25, 36, and so on. Okay, those are perfect squares. Non-perfect squares are the ones that go on forever. So these two are your key to understanding irrational numbers. So here's what I want you to do. In 9-101, there are 8 numbers. And what you need to do is decide which 4 are rational and which 4 are irrational. I just gave you the hint on the previous page. Go ahead and put these numbers into rational categories or irrational. Go ahead, pause the video now. All right, you should have this filled out. You should have 4 numbers on each side. The hint, of course, in this problem, right here. Those are the irrational ones. So let's dive into dealing with repeating numbers. This is where the bulk of the lesson is. Problem 9-102. Every rational number can be written as a fraction. That is a ratio of 2 integers. Since this number is described in words as 78 hundredths, notice 78, 2 spaces, hundredths. Oh, it can be written as 78 hundredths. Use what you know about place value to rewrite each terminating decimal as a fraction. Check your answers with the calculator. Now, here's what you learned ages ago. If you see 2 spaces, that tells you 2 zeros. So the equivalent fraction is 19 over 100. Okay, 2 spaces, 2 zeros. Go ahead and pause the video to write the decimals as fractions. Pause the video now. All right, the only problem that I want to make sure you have is problem letter C. It's a trick. It would be very easy to write this incorrectly, but notice 3 spaces tells me 3 zeros. 1 1,000. All right, let's jump into problem 103. Jessica knows that 0.57 is an irrational number, so she should be able to write it as a fraction. She wonders how to rewrite it, though. She started to rewrite it as 57 over 100, but she's not sure if that is correct. Is 57 over 100 equal to this? Be ready to justify your answer. And so notice that we have 4 lines on our paper. Now, what you need to begin by writing is 0.57 with a bar means 0.57575757. How long shall I continue? It goes on for a very long time. However, 0.57 without the bar is just plain 0.57. That's the one that's equal to this, 57 hundredths. So if I know how to make a terminating decimal into a fraction, I know that terminating decimals, the number of spaces is the number of zeros in the denominator. Okay? I don't really know about repeaters. All I know right now is the fact that these two are not equal. The question is, how do I rewrite this as a fraction? Now, this is going to get into some theoretical mathematics. If you go ahead and turn the page in your notebook, you will notice problem 9-105. Okay, 9-105 is going to have 4 lines. I'm going to write it a fair amount bigger so that I can just make it work. Here's what I want you to write on the top row. Okay, probably somewhere in like this range. Okay, 0.57 with a bar is equal to 0.57575757. How many of these should I do? Well, that's probably enough. Okay, now as a part of this mathematical proof, okay, I have to do some manipulation to these numbers. And a mathematician decided, you know, what would happen if I multiplied this side by 100? Well, I know that what I do to one side, I have to do to both sides. Okay, so in your first row, you should have what you see on the screen. In the second row, let's go ahead and multiply some of that out. So if I left 0.57 with a bar, what would happen over here on this side? Well, I know 100 times the first two is going to scoot my decimal over just a little bit. So this is going to turn into, instead of 0.57, it will be 57.57575757. Okay? And you might say, why in the world did you do that? Well, I'm getting somewhere. Now, what if I wanted to get rid of this whole repeater section? And so what I would do is I would say, well, let me take away one 0.57s. Well, that would be taking away 0.575757. See, by taking away one of the repeaters, notice, even though this goes on forever, this all subtracts out, and I am left with, in your bottom row, it should say 99 0.57s equals just plain 57. Notice how I've gotten rid of these repeaters. Now this is all four lines of your bar, and so you're going to have to write this off to the side in a second. But when we are solving equations, and our last step, when I need to isolate the variable, isolate the x, get the x by itself, we learned how to regroup. Regroup means I'm going to take the multiplication and I am going to divide it. So here's what I want you to write off to the right-hand side. 0.57 with a bar is equal to 57, the numerator, divided by 99. Notice how close 99 is to 100. And so what we can do right now is we can go back to 9-103 and we can notice that if this repeater, 0.57575757, I could rewrite this as 57 over 99. Notice how similar these two fractions are. They're ever so close. And so what rule could I write for repeaters? Well, what we have discovered just now is that the number of repeating spaces, repeater spaces, it should be repeating, sorry, spaces is the number of nines in the denominator. This is the simple fact between repeaters and terminating. Okay, the number of spaces matter, but the number of repeaters determines the nines, or terminating, the number of spaces determines the number of zeros. So let's go ahead and use this fact in problem 9-104. If I notice 99, that's going to tell me that equals 0.19 with a bar, which is 0.191919. Notice the pattern. B and C are very much the same. I'll do problem letter D as well. I notice 1, 2, 3 spaces. So that tells me 0.001. 3 repeating spaces. If I were to write that out, that would be 0.001, 001, 001. Notice the pattern. Okay? So what we have here is we are developing an understanding of the relationship of how numbers are working. What I would like you to do is pause the video, and I want you to please write the decimals for B, C, E, and F. Pause the video now. Okay. Letter G, what patterns do you see between the fraction and their equivalent decimals? Okay, I want you to notice that the numerator is always repeating. The numerator is always repeating. And the denominator tells you how many spaces repeat. Okay, so the numerator, 19, is always repeating, and the denominator, 99, is telling you how many spaces are repeating. Because let's compare that with F. F is 19 is always repeating. However, the 999 tells you that 3 spaces are repeating. There's a difference that you have to do. So let's use that pattern, and also on these lines you are going to predict what is the value of this as a fraction. And letter I, what is the decimal for 65 over 99? These are the last 2 problems for this problem. Pause the video. Okay, now what we need to do is do the opposite. If we know how to turn fractions into decimals, let's turn decimals into fractions. 0.42, well, that tells me the numerator. Okay, and how many of these spaces were repeating? 2 of them. So it tells you the number of 9s in the denominator. Pause the video to do B, C, and D. Excellent. Let's go ahead and complete the last 2 problems in this set. Now, in your notebook, you will see these numbers, and you will need to create 2 number lines. The first number line, we're going to put 0 in the center, 1, 2, 3. In the negative, -1, -2, and -3. In the second number line, we're going to have the number 10, and we're going to have the number 11, and the number 9. Okay? Now, these number lines are for comparison purposes. Okay? Now, I want you to notice we have all sorts of numbers, and the best way to compare numbers is as a decimal. Now, we have some numbers that are already as a decimal, so let's start there. 0.75. Well, here's 0, and here's -0.5. Here's -0.75. And I'm going to place that on the number line. And what I'm going to do is I'm going to go through each of these. But for me to take a square root symbol, I need a calculator. The square root of 8 in a calculator is equal to, or is about, I should say, 2.8 something, something, something. So on my number line, I'm going to say, well, I know here's 2.5, here's 2 3/4, so the square root of 8 is probably somewhere in that area. The square root of 8 is right about there. For problem 9-107 and 9-108, you need to use a calculator to compute each of these. For a pi, most calculators have a pi function. If you don't, 3.14 divided by 3. Whereas in problem 108, 3 pi says 3 times 3.14. Okay? So you need to do these problems and estimate about where these numbers will land on the number line. Please notice that I wrote the original number on the number line. Okay? All of our work today has been an understanding of different types of numbers. Square roots, pi symbols, okay? Rational, irrational. We can approximate their values so that ultimately we are able to compare. You say, Mr. McCoy, when am I ever going to do this in real life? Well, pretty soon you're going to want to buy a car. And you're going to be looking at all these different cars, trucks, new, old, fuel efficient, not fuel efficient, okay? You want a truck with, capacity to carry people, like a 4-door truck. or maybe you want a two-door truck, or maybe you want a flatbed, or maybe you want an SUV, maybe you want two-wheel drive or four-wheel drive. You're going to have all these options on the table, and you're going to have to decide the value. You are going to have to compare and contrast. You're going to have to ask yourself the value of each of these. When we do problems like this, we are deciding what is the value, and then we are going to compare them. This is a way of thinking. You might not ever compare numbers like this, but you are going to compare your options, and that is the mathematical skill we are going for today. Thank you for coming to lesson 9.2.4. We'll see you next time.